Welcome to EPA 608 Core Study Guide to Refrigerant Characteristics and Identification. In this lesson, we'll learn how refrigerants are identified, how ASHRAE classifies refrigerants for safety, and the refrigerant families commonly tested on the EPA 608 exam. We'll also cover natural refrigerants, refrigerant blends, and temperature glide. By the end of this lesson, you'll understand how refrigerants are classified, identify the most common refrigerant families, and confidently answer refrigerant-related questions on the EPA 608 exam. Let's get started. Refrigerants are identified in two ways. First, by refrigerant family, and second, by an ASHRAE identification number. The refrigerant family tells us what the refrigerant is made of. The ASHRAE number is simply a standard identification number used to distinguish one refrigerant from another. For example, HFC 134A may also be written as R134A. The letters tell us the refrigerant family, and the number identifies the refrigerant itself. The 5 refrigerant families you need to know for the EPA 608 exam are CFC, HCFC, HFC, HFO, and HC. Here's a simple memory trick. The letters in the refrigerant family name tell us which atoms are present. H stands for hydrogen, Cl stands for chlorine, F stands for fluorine, and C stands for carbon. As we move through this lesson, you'll see that understanding these letters makes refrigerant identification much easier. Another important way refrigerants are classified is by safety. ASHRAE classifies refrigerants based on 2 factors: toxicity and flammability. Toxicity is represented by a letter. Class A refrigerants have lower toxicity. Class B refrigerants have higher toxicity. Flammability is represented by a number. Class 1 refrigerants have no flame propagation. Class 2 refrigerants have lower flammability. Class 2L refrigerants have lower flammability and burn more slowly than Class 2 refrigerants. Class 3 refrigerants have higher flammability. When we combine the letter and number, we get the refrigerant safety classification. For example, A1 means lower toxicity and no flame propagation. A 2L means lower toxicity and mildly flammable. And a 3 means lower toxicity and highly flammable. When taking the EPA 608 exam, let's visualize this chart for a moment. If you remember that A comes before B, you'll know that A refrigerants are less toxic than B refrigerants. And as the numbers increase from 1 to 3, flammability increases as well. So, if you see a question comparing a 1, a 2, and a 3, you can quickly determine which refrigerant is more flammable. Instead of memorizing every safety classification, simply remember how the chart is organized, and you'll be able to work out many of the answers on the exam. We briefly introduced these refrigerant families in the last lesson. Now let's take a closer look. There are 5 major refrigerant families you'll see on the EPA 608 exam: CFC, HCFC, HFC, HFO, and HC. CFC stands for chlorofluorocarbon. HCFC stands for hydrochlorofluorocarbon. HFC stands for hydrofluorocarbon. HFO stands for hydrofluoroolefin. And HC stands for hydrocarbon. Looking at the chart, you'll notice that each abbreviation tells you which atoms are present in the refrigerant. For example, if you see Cl, that means chlorine is present. Now let's quickly review some key points from the previous lesson. CFC refrigerants have the highest ozone depletion potential. HCFC refrigerants still have ozone depletion potential, but it is lower than CFCs. HFC, HFO, and HC refrigerants have zero ozone depletion potential. We also learned that refrigerant families can have very different impacts on global warming. CFCs, HCFCs, and many HFCs have a higher global warming potential. HFOs and HC refrigerants generally have a much lower impact on global warming. Finally, notice the chlorine row. CFC and HCFC refrigerants contain chlorine. HFC, HFO, and HC refrigerants do not contain chlorine. We'll look at specific refrigerant examples in the next section. And if you're still having trouble remembering what CFC, HCFC, HFC, and HFO stand for, check out the short memory trick video linked in the description below. Now let's look at some common refrigerants. These are examples of refrigerants you're likely to see while studying for the EPA 608 exam. Unfortunately, there's no magic trick for memorizing every refrigerant number. The more questions you practice and the more examples you see, the more familiar they become. However, there are 4 key examples that appear again and again on the EPA 608 exam. R22 is an HCFC refrigerant. R134A is an HFC refrigerant. R1234YF is an HFO refrigerant, and R290 and R600A are HC refrigerants. If you're short on study time, focus on remembering these examples first. You'll see them throughout EPA 608 practice questions and study materials. Natural refrigerants occur naturally and have zero ozone depletion potential and very low global warming potential. The three natural refrigerants you should remember are R290 is propane, R600A, which is isobutane, and R744, which is carbon dioxide. Notice that R290 and R600A are both hydrocarbon, or HC, refrigerants. They offer excellent performance and low environmental impact, but they are also flammable. R744, or carbon dioxide, is different because it is non-flammable. And before we move on, remember one important safety rule. Never use propane cylinders intended for grilling as refrigerant. Although both contain propane, BBQ propane is not manufactured to refrigerant standards. It may contain impurities such as moisture or other contaminants that can damage refrigeration equipment. Always use refrigerant-grade products designed for HVAC systems. Next, let's look at refrigerant blends and learn the difference between azeotropic and zeotropic refrigerants. A refrigerant blend is simply a mixture of two or more refrigerants. For the EPA 608 exam, blends are divided into two categories: azeotropic blends and zeotropic blends. Let's start with azeotropic blends first. As you can see on the left side, azeotropic blends act like a single refrigerant. Even though they're made from multiple refrigerants, they behave almost like one refrigerant in the system. The most important thing to remember is that azeotropic blends have no temperature glide. In other words, evaporation and condensation happen at essentially one temperature. Now let's look at the right side. Zeotropic blends are different. The refrigerants inside the blend have different boiling points. Because of that, they do not evaporate and condense at one single temperature. Instead, the temperature changes throughout the phase change process. This temperature difference is called temperature glide. So if you're comparing the two, azeotropic blends have no temperature glide. Zeotropic blends do have temperature glide. That's the key difference you need to remember. Here's a simple exam tip. If a question says the refrigerant acts like a single refrigerant, think azeotropic. If a question mentions temperature glide or different boiling points, think zeotropic. Don't worry if temperature glide still sounds unfamiliar right now. In the next section, we'll look at temperature glide in more detail and see why it's important when working with refrigerant blends. Before we finish, let's review what we've learned with 3 quick questions. See if you can answer them before the solution appears on the screen. Let's begin. HCFC is an acronym for what term? Hydrochlorofluorocarbons. What statement about hydrocarbons is correct? The correct answer is A. Hydrocarbons are generally classified as 3 refrigerants, which means low toxicity but high flammability. If you chose D, be careful. Many students assume that natural refrigerants are automatically safe. That's not true. Propane and isobutane are natural refrigerants, but they are also highly flammable. Remember, natural does not mean non-flammable. R1234YF is equivalent to what designation? The correct answer is HFO 1234E. For more free EPA 608 practice tests and study resources, visit EPA608practicetest.net. Thanks for watching, and I'll see you in the next lesson.